Hello and welcome to Deep Learning, Machine Learning, and Data Science Prerequisites, the NumPy stack in Python. One question or concern I get a lot is that people want to learn deep learning and data science, so they take these courses, but they get left behind because they don't know enough about the NumPy stack in order to turn those concepts into code. Even if I write the code in full, if you don't know NumPy, then it's still very hard to read. So this course is designed to remove that obstacle, to show you how to do things in the NumPy stack that are frequently needed in deep learning and data science. So what are those things? In this course, we are first going to look at NumPy. This forms the basis for everything else. The central object in NumPy is the NumPy array, on which you can do various operations. The key is that a NumPy array isn't just a regular array you'd see in a language like Java or C++, but instead is like a mathematical object, like a vector or a matrix. That means you can do vector and matrix operations, like addition, subtraction, and multiplication. The most important aspect of NumPy arrays is that they are optimized for speed. So we're going to do a demo where I prove to you that using a NumPy vectorized operation is faster than using a Python list. Then we'll look at more complicated operations like products, inverses, determinants, and solving linear systems. Next, we'll look at a popular library called Pandas. Pandas is great because it does a lot of things under the hood, which makes your life easier because you then don't need to code those things manually. Pandas makes working with datasets a lot like R if you're familiar with R. The central object in R and Pandas is the data frame. We'll look at how much easier it is to load a dataset using Pandas versus trying to do it manually. Then we'll look at some data frame operations, like filtering by column, filtering by row, the apply function, and joins, which look a lot like SQL joins. So if you have an SQL background and you like working with tables, then Pandas will be a great next thing to learn about. Since Pandas teaches us how to load data, the next step will be looking at the data. For that, we will use matplotlib. In this section, we'll go over some common plots, namely the line chart, scatter plot, and histogram. We'll also look at how to show images using matplotlib. 99% of the time, you'll be using some form of the above plots. Finally, we'll look at the SciPy library. I like to think of SciPy as an add-on library to NumPy. Whereas NumPy provides basic building blocks like vectors, matrices, and operations on them, SciPy uses those general building blocks to do specific things. For example, SciPy can do many common statistics calculations, including getting the PDF value, the CDF value, sampling from a distribution, and statistical testing. It has signal processing tools, so it can do things like convolution and the Fourier transform. It can do many other things too, but we'll focus on the statistics stuff, because that shows up the most in deep learning and data science. So let's talk about how to make sure you can succeed in this course. The most important thing is that you code along, try things yourself, and make sure you can write all the code yourself without any reference. To get good at programming, you need to do the same things over and over again until they get imprinted into your memory. People think they can learn to do this by watching some videos on the internet. Sometimes people watch videos on the internet and then claim to know that they understand the topic they just watched a video on. So don't be like these people. One question you might have is, where can you get access to more practice activities? In this course, this is kind of a backwards question. So this course is all about giving you simple tools you can use when you learn about implementing deep learning and data science algorithms. So the best practice you can do is actually to learn about deep learning and data science topics and apply the stuff you learned here. There will be some toy problems in this course, but to see how these tools are actually used, then take a course on deep learning that looks at the implementation, and you'll be applying these tools in a real-world application. That's the best practice because it's real. As always, there are some things you'll need to know before taking this course. This course is going to be a lot easier than some of my other courses. I'm not going to assume a lot, but I have to assume some things. So here's what you'll need to know before taking this course. First, since we'll be looking at vectors and matrices, you'll need to know what those are. A full course on linear algebra would help, but we aren't going to look at anything overly complex like eigenvalues and eigenvectors. Since we'll be looking at some of the statistical functions of SciPy, you'll want to know some common probability distributions, like the Gaussian distribution, both in one dimension and in multiple dimensions. The last thing you'll need to know is Python. This is, of course, a necessity, since the NumPy stack is just made up of Python libraries. You want to have a good understanding of how code flows, if statements, for loops, functions, and you want to have used them a sufficient number of times, such that you're comfortable with them. So there isn't much you need to know, but there are a couple things. Thanks for listening, and I'll see you in the next lecture.